Okay, we'll start it now. For last lecture that Mollis law is completed. What is Mollis law? Anyone? What is statement of Mollis law? What is statement of Mollis law? Hello? Anyone?
The intensity of the polarized light transmitted through the analyzer is proportional to cosine square of the angle between the plane of the transmission of the analyzer and polarizer. This is known as Morris law.
Okay, intensity of the plane polarized light transmitted through the analyzer is proportional to cosine square of the angle between the plane of transmission of the analyzer and plane of transmission of the polarizer. This is called as Mollis law. Means I2 is equal to what? I2 is equal to, what is equation? I2 is equal to I1 into cos square
Cos
theta,
square
or
theta.
I2 is proportional to
Cos square theta.
I2 is proportional to cos square theta. This is the Mollis law. This is statement of Mollis law. Then after that, double refraction. If ray of light is incident on the isotropic medium, isotropic म्हणजे glass किंवा air किंवा water. Assume that this medium is a water medium is there. We know that water is the isotropic or anisotropic. So
Isotropic.
water is the isotropic medium. Okay, this is the boundary between the two surfaces, water and air. Air आहे. This one is water. Okay, this is the boundary between air and water. Is normal to the surface. Normal to the surface. Then a ray of light is incident on this water surface. This is incident ray. Okay, incident ray. Theta I be the angle of incidence. R be the angle of refraction. This is refracted ray. R be the angle of refraction. Then this ray, incident ray, splits into how many refracted ray for water? Incident ray splits into only one refracted ray. Means for which medium? Isotropic medium. If ray of light is incident, then it splits into only one refracted ray. What is refractive index? Mu is equal to sine of I upon
Sine
sine
of R.
of r. किंवा another equation in terms of velocity, refractive index in terms of velocity, you studied in 12th. Velocity of light in air किंवा vacuum dividing by velocity of light in which medium? This medium is water medium. Okay, velocity of light in a vacuum dividing by velocity of light in a water medium. This is the refractive index is calculated in these two formulas. First one is a sine of I upon sine of r. Second formula is C upon VW. VW means velocity of light in a water medium. Take another example for in double refraction. If ray of light is incident on an anisotropic media. Anisotropic media means examples of this anisotropic media.
Cal.
Calcite crystal, quartz crystal, these are the examples of the which medium? Anisotropic media. Okay, this is the boundary. Then air medium, normal to this anisotropic medium. Okay, this is normal to this anisotropic medium. The ray of light is incident on this anisotropic media or double refracting medium. This is incident ray. Okay, I be the angle of incidence. This ray splits into how many refracted rays? Two refracted rays. One is called as
Ordinary ray.
ordinary ray, another is called as extraordinary ray. One is called as ordinary and the second one is called as extraordinary. Assume that R1 is the angle of refraction for ordinary ray and R2 with the angle of refraction, this is R2, with the angle of refraction for extraordinary ray. And what is refractive index of ordinary ray? Anyone?
Same in all direction.
mu 0, which velocity is same in all direction. Velocity of ordinary ray is velocity of this ray, ordinary ray is same in all directions. Velocity of extraordinary ray is different in different direction. Then refractive index in terms of velocity, c means velocity of light dividing by velocity of which ray?
Ordinary ray.
Ordinary ray. We know that velocity of ordinary ray is same in all direction. This refractive index of ordinary ray is also refractive index of ordinary ray is also same in all direction. Which direction changes, then which angle of incidence changes, there is no change in refractive index of ordinary ray. Only what is changes? Refractive index of which ray? Extraordinary ray. What is refractive index of extraordinary ray? Mu is equal to c upon velocity of which ray? Extraordinary ray. We know that velocity of extraordinary ray is different in different directions, means refractive index of extraordinary ray is also different in different directions. Direction changes, refractive index changes, means difference between ordinary ray and extraordinary ray. First ordinary, second extraordinary. What is first difference? Velocity of ordinary ray is
Same in all
same
direction.
in all directions. Velocity of extraordinary ray is
Different in different directions.
okay. Second difference is refractive index of ordinary ray is same in all directions, and refractive index of extraordinary ray is different in different direction. Means ray of light is incident on this anisotropic media. Anisotropic media. Examples of the anisotropic media are calcite crystal, quartz crystal. These are the examples of the anisotropic media. If ray of light is incident on this anisotropic medium, it splits into two refracted rays. One is called as ordinary ray. Second is called as extraordinary ray. And for isotropic medium, if ray of light is incident on this isotropic medium, what happen? It splits into how many refracted rays? Only one refracted rays. Okay. If ray of light is incident on this isotropic medium, it splits into how many refracted rays are there? Only one refracted. This is the difference between double refraction, means anisotropic medium and isotropic medium. Okay. Next article is double refraction. In this double refraction, when ordinary light is allowed to pass through a calcite crystal or quartz crystal, calcite and quartz, these are the examples of double refraction. It splits into two refracted beams, kutle ordinary and extraordinary, and both are plane polarized light, and velocity of ordinary ray is same in all directions, and velocity of extraordinary ray is different in different direction. First write it now. Double refraction, write title. Okay, write it. Velocity of ordinary ray is इधर ले लेगा. Okay, velocity of ordinary ray is same in all directions, and velocity of extraordinary ray is different in different direction. Okay. Okay, this is Huygens theory of double refraction. Here, assume that if point source of light is kept in a double refracting medium, okay, point source of light is kept in a double refracting medium. आपण source of light ठेवतो आहे. आपण कुठे ठेवतो source of light? At the center of which medium? Double refracting. समजा हा calcite crystal आहे किंवा quartz आहे. सोर्स कुठे ठेवला आहे calcite crystalच्या सेंटरला. त्यावेळेस आपल्याला दोन वेव्हफ्रंट मिळणार आहेत. पहिला वेव्हफ्रंट कुठला मिळणार आहे?
Spherical.
स्पेरिकल वेव्हफ्रंट. स्पेरिकल काय मिळत आहे? velocity of ordinary ray is same in
all direction.
all direction, therefore wavefront is a
Spherical
wavefront. हा समजा ऑर्डिनरी आहे. का ऑर्डिनरी? तर velocity of ordinary ray is same in all direction. दुसरा वेव्हफ्रंट कुठला मिळणार आहे आपल्याला?
Extraordinary.
Extraordinary. Shape of extraordinary wavefront is a इलिप्टिकल. काय इलिप्टिकल आहे वो?
velocity of extraordinary rays in different direction.
ओके, वेलॉसिटी ऑफ एक्स्ट्रॉर्डिनरी रे इज डिफरंट इन डिफरंट डायरेक्शन. ह्या दिशेला वेलॉसिटी वेगळी आहे, या दिशेला वेगळी आहे. वेलॉसिटी ऑफ एक्स्ट्रॉर्डिनरी रे इज डिफरंट इन डिफरंट डायरेक्शन. That's why wavefront is a elliptical in shape. The next, according to Huygens theory, a point in a double refracting medium produces two types of wavefronts. Write it. According to Huygens theory, according to Huygens theory, according to Huygens theory, point किंवा source of light बना in bracket, source of light, a source of light point किंवा source of light in a double refracting medium, in a double refracting medium, in a double refracting medium produces two types of wavefronts, produces two types of wavefronts. Division समोर भेटा. A point source of light in a double refracting medium produces two types of wavefronts. The according the wavefront corresponding to next paragraph, the wavefront corresponding to the ordinary ray, the wavefront corresponding to the ordinary ray is a spherical wavefront. The wavefront corresponding to the ordinary ray is a spherical wavefront. Full stop. The ordinary wavefront, the ordinary wavefront, sorry, ordinary wave mana, ordinary wave travels with, the ordinary wave travels with same velocity, the ordinary wave travels with same velocity in all directions. The ordinary wave travels with same velocity in all directions, and the corresponding wavefront is spherical. Okay, the ordinary wave travels with same velocity in all directions, and the corresponding wavefront is a spherical.
त्याला खाली घेत आपला लगेच.
Second, the wavefront corresponding to second point, the wavefront corresponding to the extraordinary ray, is ellipsoid or elliptical mana. Ellipsoid or elliptical wavefront. Next line, extraordinary waves have different velocities extraordinary waves have different velocities in different directions, different velocities in different directions. काय काय assumption केले आपण सांगायचं. सोर्स ऑफ लाईट कुठे ठेवलाय सोर्स ऑफ लाईट. सेंटर ऑफ द डबल रिफ्रॅक्टिंग मीडियम. आपल्याला काय मिळालंय, दोन वेव्ह फ्रंट मिळाले. पहिला वेव्ह फ्रंट कुठला मिळाला, स्पेरिकल, आणि दुसरा कुठला आहे, इलिप्टिकल. इलिप्टिकल म्हणजे कशाचा आहे, एक्स्ट्रॉर्डनरीचा, आणि ऑर्डिनरीचा शेप कसला आहे, स्पेरिकल. आणि अजून एक गोष्ट आहे, दी स्पियर अँड इलिप्साइड टच इच अदर अलॉंग द ऑप्टिक ऍक्सिस. ऑप्टिक ऍक्सिस आहे, दे टच इच अदर अलॉंग द ऑप्टिक ऍक्सिस. अजून एकदा फिगर काढतो मी. दिस इज द सोर्स ऑफ लाईट. assume that this is the optic axis. हा जो आहे इलिप्टिकल. ओके, हा इलिप्टिकल झाला. आणि हा कुठला आहे, हा स्पेरिकल. ते कुठे टच होते, तो स्पियर अँड इलिप्साइड दे टच इच अदर अलॉंग विच ऍक्सिस,
Optic axis.
optic axis. They touch each other along the optic axis. Okay. Next, write it. Positive and negative crystals. Positive and negative crystals. Positive and negative crystals. Positive crystals and negative crystals. First, write it negative crystals. First, negative crystals. First, negative crystals. Okay. Listen, please. एक कॅल्साइट आहे. कॅल्साइट इज एक्झाम्पल ऑफ निगेटिव्ह क्रिस्टल्स. कॅल्साइट कशाचं एक्झाम्पल आहे, निगेटिव्ह क्रिस्टल्स. सी दिस इज द एस विथ द सोर्स ऑफ लाईट. इथं सोर्स ठेवलाय आपण. हे फिगर फक्त समजावून घ्या. हे फिगर समजले की सगळं. सोर्स ऑफ लाईट इज केप्ट इनसाइड द कॅल्साइट क्रिस्टल. कुठे ठेवलाय आपण, कॅल्साइट क्रिस्टल. आपल्याला दोन वेव्ह फ्रंट मिळाले. पहिला हा कुठला आहे, वो ऑर्डिनरी, आणि हा कुठला आहे, एक्स्ट्राऑर्डिनरी. आता ह्या दिशेने जर घेतले आपण, कशाची व्हेलॉसिटी जास्त आहे, हो एक्स्ट्राऑर्डिनरी. कशापेक्षा, ऑर्डिनरी पेक्षा. म्हणजे कुठला वेव्ह फ्रंट इनसाइड आहे, ऑर्डिनरी वेव्ह फ्रंट. आणि कशाचे, कुठला आउटसाइड आहे, एक्स्ट्राऑर्डिनरी. म्हणजे निगेटिव्ह क्रिस्टल मधला पहिला पॉइंट काय येणार आहे, द स्पेरिकल मीन्स ordinary wavefront is entirely within the ellipsoid. Ellipsoid means
Extraordinary wavefront.
wavefront. This sphere lies inside the ellipsoid. लक्षात आलं का. आपण हे निगेटिव्ह क्रिस्टल एक्झाम्पल, निगेटिव्ह क्रिस्टलचं कॅल्साइट आहे. कॅल्साइट मध्ये जर आपण सोर्स ठेवला तर आपल्याला दोन वेव्हफ्रंट मिळतात, ऑर्डिनरी आणि एक्स्ट्राऑर्डिनरी. एक्स्ट्राऑर्डिनरी वेव्हफ्रंट कुठं आहे, आउटसाइड आहे, आणि ऑर्डिनरी वेव्हफ्रंट कुठं आहे, inside. This is the first point in negative crystals. Second point, in negative crystals, in terms of refractive index, ordinary refractive index of ordinary ray is mu0, and refractive index of extraordinary ray is mu e. इथे आपण notations ne आणि n0 वापरले. ठीक आहे, ओके. Here c upon v0 आणि mu v is equal to C upon V. आणि V0 आणि V मध्ये रिलेशन काय आहे, which is greater, V is
greater than V0.
म्हणजे आता mu0 आणि mu मध्ये काय असणार आहे रिलेशन, लक्षात येते का मी काय म्हणतो ते. velocity of extraordinary ray is greater than velocity of ordinary ray, आणि here refractive index of ordinary ray is this equation, mu0 is equal to c upon v0. Refractive index of extraordinary ray is c upon ve. दोन्ही मध्ये v0 आणि ve मध्ये काय जास्त आहे, ve जास्त आहे. म्हणजे काय येणार आहे हे दोन्ही मधलं रिलेशन, mu0 आणि ve मधलं हा V0
Yes.
which is greater. लक्षात येते का अजून एकदा? ठीक आहे, अजून एकदा रिपीट करू. साधी गोष्ट आहे हो, अतिशय सिंपल आहे. डिनॉमिनेटर जास्त आहे, ज्याचा डिनॉमिनेटर जास्त त्याची व्हॅल्यू काय येणार आहे? कमी येणार आहे. साधी गोष्ट आहे, ज्याचा डिनॉमिनेटर जास्त त्याची व्हॅल्यू काय येणार आहे? कमी येणार आहे. आता एकदा लक्षात घ्या, अजून एकदा. आता सेम नोटेशन्स विल यू. N0 means refractive index of ordinary ray is equal to C upon V0 आणि NE means refractive index of extraordinary ray C upon VE. तर V0 आणि VE मधलं रिलेशन काय आहे हो? V0 is
Greater than mu.
V0 is
Less than.
less than V. आता मग ह्या N0 आणि NE मधलं काय येणार आहे? N0 is
Greater than.
NE. हा म्हणजे सेकंड पॉइंट आहे. सेकंड पॉइंट. In negative crystals in which refractive index corresponding to E ray म्हणजे extraordinary ray म्हणजे NE is less than the refractive index of ordinary ray म्हणजे कुठला? N0 in all directions except along the optic axis. Except along optic axis काय म्हटलंय? See along this optic axis in this direction दोन्ही सारखंच आहे. V0 is equal to VE. किंवा ह्या दिशेने घ्या, इथे S be the source of light, S be the source of light in this direction along the optic axis. V0 is equal to VE. The refractive index of ordinary ray is equal to refractive index of extraordinary ray. कुठल्या दिशेने? Along the optic axis. म्हणजे optic axis च्या दिशेने the sphere and ellipse that they touch each other along which axis? Optic axis. In the direction of optic axis, velocity of ordinary ray is equal to velocity of extraordinary ray. Means sphere and ellipse that they touch each other along which direction? Optic axis. Okay. What is second point? We'll tell. This one. In negative crystals. हॅलो, ऑनलाईन मध्ये एखादा विचारत तुमच्यापैकी सांगा कोणीतरी. N0 आणि NE मध्ये रिलेशन हेच फक्त स्टेटमेंट मध्ये मांडायचं आहे. इन निगेटिव्ह क्रिस्टल्स द रिफ्रॅक्टिव्ह इंडेक्स ऑफ
Ordinary rays is greater than the refractive index of extraordinary rays.
Okay, in negative crystals the refractive index of ordinary ray is greater than the refractive index of extraordinary ray except along
Optic axis.
except along the optic axis. Right, second point. पहिला point लिहिलाय का? First draw the figure first. First draw this figure. In this figure show ordinary wavefront lies within the extraordinary wavefront. Ordinary wavefront lies within the extraordinary wavefront. This one is the ordinary. This is extraordinary. Complete it. I will give 2 to 3 minutes. Please complete it. Hello, draw this figure carefully. Show first ordinary wavefront आतमध्ये आहे, extraordinary wavefront is outside, आणि ही दोन्ही एकमेकाला टच झालेत. कुठल्या दिशेने टच झालेत? Along the ऑप्टिक ऍक्सिस. असं दाखवायचं नाही की आतमध्ये ऑर्डिनरी दाखवलाय आणि बाहेर मध्ये एक्स्ट्रा ऑर्डिनरी दाखवलाय. दोन्ही कुठेच टच होत नाहीत. डोंट शो लाईक दॅट. मे बी काय काय जण कसे दाखवते तुम्हाला एक सॅम्पल दाखवतो. दिस इज ऑर्डिनरी वेव्ह फ्रंट आणि हा बाहेरचा एक्स्ट्रा ऑर्डिनरी. कुठे टच झालेत का हो दोन्ही एकमेकाला? नाही. ओके, आपल्याला काय दाखवायचं? दे टच इच अदर अलॉंग विच डायरेक्शन?
along optic axis.
ऑप्टिक ऍक्सिस. का टच होतात तर velocity of ordinary ray is equal to velocity of
Extraordinary.
along the optic axis. Okay, show it carefully. झाली का फिगर सगळ्यांची?
Yes, sir.
Yes, no?
Yes, sir.
Okay.
Yes, sir.
Okay, write it then. Negative crystal मधला point number 1. The spherical wavefront. Spherical wavefront. Spherical wavefront. कंसात ORA म्हणा. ORA म्हणजे ordinary wavefront. The spherical wavefront is entirely within the ellipsoidal wavefront किंवा E wavefront. The spherical wavefront is entirely within the ellipsoidal किंवा E म्हणजे extraordinary wavefront. Spherical is ordinary wavefront is entirely within the ellipsoidal means extraordinary wavefront. Point number 1. Okay. Then second point is relation between refractive index of ordinary ray and extraordinary ray. This n0 is greater than ne. In negative crystals, in negative crystals, refractive index corresponding to extraordinary ray, that is ne, refractive index corresponding to extraordinary ray ne is less than refractive index corresponding to extraordinary ray Ne is less than the refractive index is less than the refractive index corresponding to ordinary ray in bracket N0 in all directions except which axis?
Optic axis.
ऑप्टिक ऍक्सिस कंसातल्या दॅट इज इन शॉर्ट मध्ये आपल्याला एमसीक्यू साठी पाहिजे असतं हे N0 इज फॉर निगेटिव्ह क्रिस्टल्स N0 इज
Greater than
N आपल्याला हे महत्वाचं एमसीक्यू साठी हे पाहिजे N0 इज ग्रेटर दॅन Ne किंवा काय काय बुक मध्ये μ0 पण वापरला असेल μ0 इज ग्रेटर दॅन μe μ0 म्हणजे रिफ्रॅक्ट इंडेक्स कशाचा रिफ्रॅक्ट इंडेक्स ऑर्डिनरी रे आणि μe म्हणजे
extra refractive index of
एक्स्ट्राऑर्डिनरी रे हे एमसीक्यू साठी आपल्याला पाहिजे ते लक्षात ठेवा लिहून ठेवा लागेल थर्ड पॉइंट कोणाची वेलॉसिटी जास्त आहे व ह्या दिशेने प्रत्येक इन दिस डायरेक्शन वेलॉसिटी ऑफ व्हिच रे इज
extraordinary ray
greater than means v is
greater than V0
v is greater than v0 except along which axis
optic axis
write it the extraordinary ray travels faster than ordinary ray that is ल्या ब्रॅकेट मध्ये एमसीक्यू साठी आपल्याला v is greater than v is greater than v0 except along the optic axis except along the optic axis an example is a calcite is an example of which crystals negative crystals calcite is example for negative crystals the short मध्ये कोण सांगताय मला पहिला पॉइंट इन शॉर्ट फर्स्ट पॉइंट इन शॉर्ट sphere lies inside the
elliptical
okay sphere lies everyone please write in short here figure च्या कडाला कुठेतरी शॉर्ट मध्ये लिहून ठेवा sphere lies inside the ellipsoidal फिगरच्या कडाला हे सगळे पॉइंट शॉर्ट मध्ये एकदा लिहून ठेवा आपल्याला एमसीक्यू साठी लागतात स्फिअर लाइज इनसाइड द इलिप्साइड सेकंड पॉइंट रिलेशन बिटवीन N0 and Ne
N0 is greater than Ne.
okay N0 is greater than Ne 15 मिनिटांनी सुटलं N0 is greater than Ne आणि थर्ड
V is greater than V0.
V is greater than V0 आणि एक्झाम्पल कॅल्साइट हे झालं कशासाठी negative crystal साठी okay then for positive crystals draw this figure and write similar explanation for positive crystal also okay draw the figure and write similar explanation चुकलं काय हो बरोबर आहे ना पॉझिटिव्ह मध्ये काय आहे हो which is inside एक्स्ट्राऑर्डिनरी इनसाइड आणि आउटसाइड ला काय आहे ऑर्डिनरी आहे त्यानुसार बाकीचे सगळे चेंजेस होणार आहे. आणि एक्झाम्पल कुठला आहे याचं? क्वार्ट्ज क्रिस्टल. Okay, quartz is an example of positive crystals. You take time, write all the points also. Just don't draw only figure, write explanation also. Previous explanation for negative crystals. जसे निगेटिव्हचे लिहिले तसेच पॉझिटिव्हचे सगळे 4चे 4 पॉइंट लिहायचे. ज्याप्रमाणे निगेटिव्हचे 4 पॉईंट लिहिले त्याचप्रमाणे पॉझिटिव्ह क्रिस्टलचे पण 4 पॉईंट लिहायचे आहेत. प्रत्येकाने लिहायचे आहेत. Rule number 1, 2.
Yes, sir.
Rule number 4, 6, 7, 8, 14. Rule number 14, 1, 4. 16, 17, 18, 19, 20,
Present, sir.
23. Rule number 23, 20, 25. 25 आहेत का? 25 नंबर. 26. Hello. 26. 27. 31. 32. 40. 42. Roll number 42. 43. 44. 45. 46.
Present, sir.
47. 47. 53. 54. 54. 55. 56.
Present, sir.
57. 50. 62. 63. Absent number, roll number 8, roll number 25, 26, 42, 47 आणि 54. कधीतरी येते. कधीतरी असतात. Okay, what is first point? Who will read the first point? Anyone?
Elliptical wavefront is entirely within the spherical wavefront.
Okay, the elliptical wavefront is entirely within the spherical wavefront. What is second point?
In positive crystal, refractive index corresponding to extraordinary ray is greater than refractive index of ordinary ray.
Okay, refractive index of extraordinary ray is greater than the refractive index of.
Extraordinary.
Okay, second point, refractive index of extraordinary ray means NE is greater than.
N0.
NE is greater than N0. What is third point? Which velocity is greater?
V0 is greater.
V0 is greater than
VE.
VE. This velocity of extraordinary ray is less than the velocity of ordinary ray except along the which axis?
Optic axis.
Optic axis. And what is last one is example of this positive crystal is a
Quartz.
quartz is the example of positive crystals. Okay. In short, write the points. Point number 1. Which wavefront? Elliptical wavefront. In short, write it everyone near to this figure. Elliptical wavefront lies inside the
Spherical wavefront.
spherical wavefront. At point number 1, elliptical wavefront lies inside the spherical wavefront. Second point,
NE is greater than
okay, NE is greater than
N0.
N0. What is third point?
V0 is greater than
V0 is greater than
VE.
VE. And last point is
Example.
example. Which is the example?
Quartz.
Quartz is the example for which crystals? Positive crystals. Okay, this is for positive crystals. This calcite cause, these are the examples of double refracting mediums. There are two types of double refracting mediums, positive crystals and negative crystals. Okay, right, next is our next article, write it optical activity. Optical activity. Optical activity. Hello. हे झालं का लिहून सगळ्यांचं पॉझिटिव्ह क्रिस्टल? हॅलो.
झाले सर.
ओके, राईट ऑप्टिकल ऍक्टिव्हिटी. Optical activity. Okay, listen please. This is unpolarized light. Okay, unpolarized light. This unpolarized light. प्रत्येक जण ऐकताय का? हॅलो. Unpolarized light pass through the polarizer. We are getting which light? Plane polarized light. Okay, this is the PPL, plane polarized light. This unpolarized light pass through the polarizer. We are getting plane polarized light. This plane polarized light pass through this optical active substance. It's optical active substance आहे. Okay, this plane polarized light pass through this. Okay, this is unpolarized light. is unpolarized light. Pass through this polarizer, we are getting plane polarized light. This plane polarized light pass through this optical active substance. Then this plane of vibration is rotated inside this crystal or inside this optical active substance. This plane of vibration or plane polarized light, plane of vibration of this plane polarized light is rotated inside this optical active substance. This property of rotating the plane of vibration is called as optical activity. It is called as optical activity. See this figure. This is unpolarized light. Is passed through this polarizer. This is polarizer. Second one is the polarizer. See, this is the polarizer. Pass through this polarizer. We are getting which light? Plane polarized light. This plane polarized light pass through this tube. This tube is filled with the sugar solution. Assume that it is completely filled with the sugar solution, and sugar is the optical active substance. Sugar कसला substance आहे? Optical active. Okay? This plane polarized light pass through the sugar solution. Then see here, this plane of vibration is rotated inside the sugar solution. कशामध्ये rotate होतात? The sugar solution मध्ये. This property of rotating the plane of vibration is called as
Optical activity.
is called as optical activity. Once again, yes, be the source of light. This is unpolarized light. This unpolarized light pass through the this unpolarized light pass through this polarizer. We are getting plane polarized light. This plane polarized light pass through this tube. This tube is filled with the कशाने fill up केलेले आपण
Sugar solution.
sugar solution. Sugar is the optical active solution. Okay, this plane of vibration is rotated inside this sugar solution. This property of rotating the plane of vibration is called as
Optical activity.
optical activity. Okay, there are two types of optical active substances. पहिला कुठला आहे? Dextrorotatory, and second one is the levorotatory. Okay, right? First definition. Definition of optical activity, write it. The ability of substance the ability of substance in bracket write it, crystal or solution. The ability of substance to rotate the ability of substance to rotate the plane of polarization the ability of substance to rotate the plane of polarization to rotate the plane of polarization. The ability of substance in bracket crystal or solution to rotate the plane of polarization about the direction of light is called as optical activity. And here in this make underline for rotate plane of polarization. The ability of a substance to rotate plane of polarization is called as optical activity. Next line. The substance which can rotate plane polarized light The substance in bracket crystal or solution which can rotate plane polarized light is called as optical active substance. Is called as optical active substance. Is called as optical active substance. Next line. There are two types of optically active substances. There are two types of optically active substances. First one is a dextrorotatory and second one is the leorotatory. There are two types of optical active substances. First one is the dextrorotatory, second one is leorotatory. Okay, in detail we'll see for next lecture. Now we'll stop it here. There are two types of optical active substances. First one is the dextrorotatory and second one is the leorotatory. Okay, for next lecture we'll see. We will stop it now. Thank you.